Hello guys, we are anxiety students delivering a presentation on the course Internet High Layer Protocol research paper. Our topic is engineering Egress with edge fabrics steering oceans of content out to the world. My teammates are Geetika, Bharat and Ritik. Moving on to next slide, introduction. Edge Fabric is a traffic engineering system developed by Facebook. Internet traffic has evolved significantly in the past decade. Border Gateway Protocol remains largely unchanged despite massive traffic and topology changes. Some limitations in Border Gateway Protocol path selection, like especially for large volumes of adaptive bitrate video traffic. Here, the Border Gateway Protocol making a performance-aware routing decisions and describe the network connectivity and traffic characteristics that makes it difficult for providers to manage their egress traffic effectively. Moving on to next slide, we can know about the Border Gateway Protocol. The Border Gateway Protocol is a protocol used to route traffic over the internet. It is the main protocol used by internet service providers to exchange routing information and determine the best path for data packets to reach their destination. Border Gateway Protocol is responsible for making routing decisions based on the factors such as length of the path and capacity interconnections. BJP is not capacity aware, leading to the congestion in some scenarios. Coming to capacity awareness, BGP does not consider the capacity constraints for internet connections and paths, leading to potential congestion issues, especially with the high volume video traffic. Border Gateway Protocol is not performance aware, resulting in suboptimal performances. Coming to performance awareness, Border Gateway Protocol relies on attributes such as path length and multi-exit discrimination for path selection, which may not correlate with optimal performance. Border Gateway Protocol lacks native support for assigning performance sensitive and elastic traffic to the different paths. Moving on to the next slide, point of presence. The point of presence means it is a location where telecommunication or network service providers place their equipment to internet connect and exchange traffic. The architecture and strategies employed by Facebook to reduce these latencies. Facebook has established the point of presence in numerous global locations, each equipped with racks, servers connected to intermediate aggregation switches like ASW, and multiple peering routers PR. Here, ASW maintaining the border gateway protocol sessions with multiple peering routers, rack switches. Moving on to the next slide. Here, the figure 2 describes that relative egress traffic volume of 20 pop. It indicates that where difficulties managing the egress traffic due to the rich connectivity and varied the traffic characteristics. To address these challenges, Facebook introduced Edge Fabric, a system to optimize routing for egress traffic. And Edge Fabric receives Border Gateway Protocol, monitors the capacities and demand dynamically, determines how to assign and traffic to routes. Overcoming the limitations, the system has been in over for 4 years. It's designed the evaluation to indicate the traffic originates from clients approximately 95% and 65,000 prefixes. Here, figure 3 illustrates that distribution of client prefixes needed account for 95% of each point of present traffic. And going to next slide, the inter-domain connectivity. Inter-domain connectivity plays a crucial role in functioning of internet. It allows different autonomous systems to connect exchange traffic, enabling the users to access content and services from various providers. Different types of connections. First one, Border Gateway Protocol connection types. Transit provider. These provider routes to the prefixes through the dedicated private network interconnect. Peers. They offer routes to peers, prefixes, and customer code. There are different types of peer connections, including private peers, public peers, and root server peers. Routing and configuration. Multiple peer routings in point of present may connect to the same as for capacity and failure resilience. Facebook network is configured to address a flow of only at point of present, where the flow enters, reducing the backbone utilization and simplifying the routing decision. Moving to the third slide, border gateway protocol configuration preferences. Peer routing are configured to prefer peer routers over transit routes with a path length as a tiebreaker. Here, the preference order is private peers greater than public peers are greater than route servers. And the fourth one is connectivity and traffic handling. Facebook has thousands of peer automatic switches, and each point of presence has 100 of peer, indicating rich connectivity. Traffic is isolated with the point of presence, improving system stability, reducing the backbone utilization, and simplifying the routing decision. Coming to the next slide, challenges of border gateway protocol. There are three challenges faced by the Facebook in the context of border gateway protocol. Introduces their solution and edge fabric. First one, peering capacity, limitation and border gateway protocol lacks of capacity awareness. The challenge was as Facebook demand infrastructure expanded limitation in border gateway protocol. It became apparent. Border gateway protocol is not aware of peering capacity and rapid growth or short-term spikes in demand. It can overwhelm existing the interconnections, causing congestion and reducing the performance. Here the solution was Edge Fabric is introduced as a system to enable the capacity aware aggress decision on the top of border gateway protocol. It prevents that dynamically managing the traffic and capacity aggress links. Coming to the second challenge, impact on performance due to border gateway protocol decision. The challenge was Facebook border gateway protocol policy aims to optimize network traffic performance by favoring certain paths based on the heuristic like automatic switching path length. The solution was Edge Fabric is designed to address the performance to impact of border gateway protocol decision. It introduces a system to measure and compare the performance of alternative paths, allowing for more informed routing decision. Going to the third challenge, the comparison of latency on different paths. Here, the severity of performing issues is illustrated comparing on the latencies of border gateway protocol. The challenges which are included to limitations, border gateway capacity, awareness, potential congestion issues that impact the border gateway protocol decisions on network performance. The solution was HFabric is presented to address these challenges by introducing the capacity aware aggress decision and improving the performance of routing decision. The next slide will be continued by Geetika.
Thank you, Bharat. So from here, I'll be continuing the presentation. So this is Geetika. So the next step of the presentation is like goals and the design. So this Edge Fabric is a traffic engineering system developed by Facebook. So to address the limitations of BGP and optimization interdomain connectivity for improved performances. So coming to the diagram, this is an Edge Fabric components. So the first one is the BMP collector, and the traffic collector goes to the allocator, and then it goes to the router overrides, and then BJP injector, and then from directly it goes to the periodic. So I'll explain you clearly about like each and every components in the next slide. So but can you go to, yeah. So the first one is the BMP collector. So the BMP collector plays a crucial role in providing the necessary BJP related data to the collector and the controllers, allowing edge fabric to optimize routing decisions. So based on the real-time information about the network's BJP dynamics. So coming to the traffic collector, so this component is that plays a role in gathering and collecting the information related to network traffic. So coming to the next one is the allocator. So this allocator like plays a specific role in image in not explicitly detailed but based on the general networking principle. It may involve resource allocation, the routing balance, or path selections, or dynamic routing decisions. So this allocator could be responsible for allocating resources such as bandwidth or routing or different parts of routers within the network. So coming to the this also based on the real-time measurements and the data is collected by the other components like the traffic collector. So route overrides. So this route override is refers to a capability of routing the system to manual or programmatically alter default routing decisions. So coming to the next one is a BJP injector. So this BJP, so injector typically refers to the system of the component. So injects BJP routes into BJP speaking networks. So route override, but coming to the route override, so this route overrides refer to a capability of a routing system to manually or programmatically alter the default routing decisions. So the last one is a peer routing. So this peer routing refers to typically routers that are involved in the process of peering practically in the concept of internet connections. So this peering is a relationship between the two networks. So usually the internet service providers or the larger networks where they agree to exchange the traffic directly instead of routing it into a third party networks. So this peering is also a volunteer interconnections of administratively separate internet networks for the pursuit of exchanging traffic between them. So this can happen at various levels, so including between the ISPs or content delivery networks or other entities that can exchange significant amounts of data. So coming to the next slide. Yes. So coordinating with the global load balancer. So after all, so we need to get coordinated with that. So configuration, edge fabric, and the global load balancers of network together seamlessly, like preventing oscillations in traffic due to collecting decisions. So this load balancer configuration uh, ignores like routers injected by the edge traffic or considering routes that can be used in the absence of an override. So deploying and testing and monitoring. So deployment edge fabric like weekly within a multi-stage releases. So this process including automated tests, shadow instances of comparison and pop-up by pop revisions. So monitoring of misconfiguration. So monitors compares the controller's projections with actual so this with actual edge fabric output against the current network state and the traffic patterns to detect micro configurations. So the next step, coming to the next slide. So this the capturing network state. So this routing information. So this utilize the BJP monitoring protocol. So to gather all the available routers for prefix and emulates the BJP best part of the solutions or the selections to their preferred path. So this traffic information. So this collects the correct traffic rates per prefix. So using traffic collector and then considering the data to more accurate representation. So interference information. So this reveals the informations about interfaces in each peering and then project interfaces. They utilize the based on emulated BJP path selections. So generating overrides. So This allocator projects interferes the utilization and the identifies the interfaces that will be overloaded without interventions. So this decision rule generates overrides the shift of the traffic based on the specific rule, including the preferred IPv4 and IPv4 5, considering the peer preferences seeking to the routes with the longest prefix BJP best path and using the consistency stainless allocation process. This operates in a strategies manner, generating in the allocation of every 30 seconds. So next slide. So enacting allocated override. So this is nothing but just the output. So the BJP updates. So this BJP for each fabric overrides assigns high local prefer values and send them to the BJP injector services. So enhance overrides by announcing BJP updates to peer routers or ensuring all routers prefers that injector route withdrawals and invalid overrides. Next slide. So, towards performance aware routing, so placing traffic or alternate paths, the main object, the objective of this is overcoming BJP limitations for destination based routing, flow market by servers. Servers play a crucial role in the process. So, explain how we can mark specific flows by manipulating the D DSCP field in IP packets. So DSCP means it's like differentiator service cloud point is used to signal specific treatment or each packet. So next coming to this is the policy routing at peer routers PRS. So here we can like analyze the DSCP values set by the servers to make routing decisions. The DSCP value correspond to a specific alternate routing table. Coming next is the mechanism. So like how this the whole flow and like everything works is one of the most important thing what we are looking here. So the in this mechanism, like server make floors like using this DSCP fill in IP packets. So this policy routing at peer routers route packets based on DSCP values. Controllers injects routes to alternate routing table at PRS. Next slide. So, measuring performances at alternate paths. So, the objective of this is to the continuous of measurement of multiple paths for the better decision making. So randomly selecting the floors or alternate path measurements, injecting alternate routes based on the BJP injector, or logging performances metrics at the connection termination. So for the future uses of performances aware routing, so here leveraging the performances measurement for improved use experiences, potential applications. So, enhancing the edge fabric decisions using the art measurements, optimizing the limited capacity by prioritizing the high priority floors, assisting in the network planning decision based on the performance impact. So, these are the measuring performances of alternate parts and the future use performances of the ever routing. So, next slide. So from this, Ritik will be continuing the presentation.
Hi everyone, this is Ritik. So I'll be mainly discussing about results on production traffic and operational experience. And this is result on production traffic. So Edge Fabric was developed for all production traffic and detour traffic to avoid all overloading interface at POPs around the world. So preventing congestion. So first one is Edge Fabric performance evaluation. So in this, preventing congestion is a result. Edge Fabric successfully prevents aggregation interface from becoming overload by detouring traffic to alternate routes. So then second one is non-overload alternate routes consistently available during this study. So here is a graph about detouring traffic statistics. It mainly illustrates the distribution of fraction of time edge fabric detoured traffic from interface, and it shows the effectiveness of edge fabric in managing traffic and overloading. So this graph mainly deals with fraction of time edge fabric detours from interface. So this figure shows complementary cumulative distribution functions, that is CCDF, of interface versus the fraction of time on interface overloaded, suggesting how often an edge fabric needs to reroute traffic to prevent congestion. So this accompanying test explains the purpose of effectiveness and operational dynamics of edge fabric in managing network traffic. So it also indicates that edge fabric is successful in preventing congestion by rerouting traffic and provides statistics on edge traffic detouring, such as percentage of interface detouring the direction of detours. And the next slide. It also next, and this is okay. This is improvement in latency. Altput identified 400 destination prefixes with faster median latencies on alternate routes, result in improved performance for 45% of prefixes by at least 20 ms and 28% by at least 100 ms. So the above graph it is a distribution of edge fabric detour period lengths across space of time and between detours. This figure mainly includes two lines. One is red and one is blue, representing complementary cumulative distribution function for two different metrics related to network traffic managing by edge fabric. And red line is called detour duration and blue line is called gap detour duration. And detour duration of frequency is also known as the distribution of edge fabric detour period lengths and time between detours. Median detour lasts at least around 22 minutes with varying distributions and frequencies. And the below graph, it deals with fraction of traffic detoured by edge fabric across 20 POPs, and the POPs with the largest fraction detoured. It also displays two lines. One is red and one is blue. And red line deals with global traffic, and blue line deals with traffic at POP with most detours. And the global traffic patterns depicts the fraction of traffic detours across 20 POPs and the fraction of detours at the POPs with the highest detour fraction. And next slide. It is also results of edge fabric, and one is spare capacity and dynamic detour. Edge fabric enables dynamic detour from interface to avoid overloading. Detour traffic remains the fraction of overall traffic, leaving spare capacity to observe detours. And performance impact analysis. This graph represents the performance between path chosen based on BJP policy and alternate path measures. Demonstrate the successful of using measurements to override BJP decision for actual production user traffic at POPs. And it mainly deals with cumulative distribution function and edge fabric compared to BJP with primary path. On x-axis, we have different median latency in milliseconds between the two paths. A negative value indicates that edge fabric selected path had lower latency than BJP primary path. Hence, the better performance is observed. And the y-axis represents the cumulative fraction of samples that have latency difference less than or equal to value on x-axis. And from here, it deals with over operational experience. And it also is an evolution of edge control from state to stateless control, transition from stateful to stateless implementation for implicity and scalability. Stateless control makes allocation and override decision in 30-second cycle without awareness of previous detour. Advantage include ease of testing, restarting, and failover without complexity of stateful recording. And next one is from host-based to edge-based routing. Shifted from host-based routing to using BJP for overrides. Previous model relied on host-based rules on every server, complementing configurations and synchronization. Edge-based approach simplifies troubleshooting, provides better synchronization, and empowers PRs to handle override. And from global to per POP aggregation options. Previous propagate routes across POPs for improved performance. Introduction mechanism to prevent oscillation in case of route overrides causing aggregation POP changes. Later, disable route redistribution between POPs for simple aggregation at the same POPs and as ingress. Next slide. So, and from balance to imbalance capacity. Adapt edge fabric to handle imbalance capacity among peers in growing POPs. Choosing this approach over adopting WCMP due to vendor support, adoption risk, and potential complexity. Edge fabric can identify and address imbalance for specific prefix within seconds. And last one is the challenge of internet exchange points. Internet exchange point present challenge due to limited visibility into peers port capacity. Setting limits on traffic to avoid congestion requires collaboration with large public exchange pairs. Capacity constraints are established by obtaining estimated limits on the minimum traffic rate from on to maximum traffic rate from exchange pairs. Overload on these connections is handled similar to regular PNI interface with utilization limits next HOP. And this is C&D traffic engineering, which is also known as common approach in centralization control networking. Common approach involves centralization, control common network, and traffic information for configuration device. Various proposals include any cached and DNS extensions focus on directing client requests to nearby servers, complementing edge fabric. And the last one is intact Espresso and edge fabric compression. Intact and Espresso are similar. Intact balance performance, load, and cost, while Espresso is Google's SND based Egress routing system. Edge fabric uses passive measurements for path performance, whereas Intact relies on active measurements and has emulation based evaluation. Next slide. So before Swan and fibbing. So this mainly involves with routing system. Before and Swan's centralized control for inter data center network to maximize utilization. Edge fabric has similar goal but operates in open environment, controlling aggregation traffic to external networks. Webben centralized and control for legacy OSPF networks, but edge fabric interdomain setting has less visibility into end-to-end paths and performance monitoring. Existing techniques measure path performance through active or passive methods. Edge fabric conducts passive measurements at Facebook servers, allowing monitoring of all path services without instrumenting clients. The use of passive measurements provide richer metrics compared to on-path device. Similar finding to previous IHLP characterization studies, highlighting congestion issues on a small number of interfaces. Next slide. And conclusion. In this, edge fabric has evolved to prioritize simplicity, scalability, and flexibility in response to the growth of POPs and operational learnings. The transition from stateful to stateless control, host-based to edge-based routing, and global to POP egress option showcases the continuous effort to streamline and optimize the network control system. The choice to handle imbalanced capacity with edge fabric reflects a practical approach to address operational approach. And operational experience. Operational experience over 4 years is shared, embracing the challenges and opportunities faced in engineering egress traffic for a large content providers. The paper highlights edge fabric success in avoiding congestion on a capacity constrained interconnections and future of BGP. Acknowledgement that BGP will continue to be standard for interdomain routing in the foreseeable future. But next slide. And then